Hello, everybody. Many thanks for joining our webinar on circular economy with a focus on circular nutrients. We are very happy to be able to present this topic to you. With me are two speakers from the corporate side with the challenges and two very young startups that provide their solutions here. First of all, from our initiating partner, K+S, Matthias Hübner. He is running the topic of circular economy within K+S, and he is sharing what for best practices K+S is already active in and what the demands are and how that is then also linked to the market and why K+S is an important market player on that one. Then I'm very happy to welcome Daniel Klein here from the Emscher Lippe Verband, actually the biggest water treatment organization in Germany. Phosphor or recycling of phosphorus is a huge topic that's coming up very soon. 7 years is not a long time. So many thanks, Daniel, for joining here. And now on the startup side, I welcome Sebastian from Alp Elements. Heavily salt content in water is just what Sebastian needs with his solution. He just started the company and enables wastewater as a source for microbial production and is showing what the potential is there. And last but not least, from Argentina, Diego, he's actually a neighbor as well. So the company is located also in our building on a different floor. He will show us what can be done with sludge biochar and how the incorporated nutrients can be enabled and made bioavailable by addition of microbes and the soil microbiome or specific microbiome components. I'd like to introduce the RootCamp. Why are we able to actually bring this webinar to you? What is our role here and what do we have to offer? I'm sharing a few slides now. We started RootCamp as an innovation hub in 2020. We focus on the agri-food value chain and try to bring innovation from the startup side into the industrial environment and actually have this corporate innovation by startup inspiration. Therefore, we need different partners, we need challenges, we need a lot of different solutions from the startup side. And I'd like to explain you now a little how we set up this innovation hub and what are we exactly doing at RootCamp. So we are sponsored by the industry, initiated by K+S, our biggest partner. K+S is a mining company looking at potash and also mining stone salt. Matthias Hübner will give you a deeper insights into K+S later. We have other partners as well, like KWS producing seeds, and SKW, the biggest nitrogen producer in Germany, and also obviously the biggest nitrogen fertilizer producer in Germany. We have, in addition, also local partners like the Hannover Impulse as a local economic support agency. It is very important for us to be here in the region because we source our startups globally, and therefore it's good to have here the ability to also source the local ecosystem. For all our partners, we have different packages, and we always try to match the demand with our services. And not only from the RootCamp side, but we are also part of a larger organization, the SpinLab group, started by the SpinLab Accelerator in 2015 in Leipzig. And now we also have a venture arm and also a consultancy attached. So I said we are in Hannover. This is our home. We are right in the city center of Hannover, combining the RootCamp Innovation Hub, but also the Biointelligence Incubator. That is a publicly supported organization from the local Leibniz University of Hannover, holding 14 startups also in the fields of bioeconomy, pharma, and also diagnostics. So that is great to have the whole building here focusing on biology and innovation. It is also very well located in terms of public transport, and it's the capital of Lower Saxony, the biggest industrial agriculture area in Germany. We are running an acceleration batch. These are the companies we had in our batches 1 to 3, covering quite a range of different technology topics. We are happy to always make an intro to the startups. You can see them all on our website, where we provide additional information to them. Our products are based on 3 pillars. For entrepreneurship, we offer creation. So whenever an employee has a good idea, wants to change something different or include extra innovation, we help them with our startup methodology. Then the inspirational part, this is our flagship, hosting our acceleration program. So we try to source innovation-driven companies, early stage, deep tech companies from all over the world to offer them the acceleration or participation in our acceleration program. It is a 12-week program that is being conducted here at Hannover, at least with 2 or 3 presence weeks. Otherwise, we are going to have it virtually since the companies are internationally sourced. But that is our flagship, and the startups are being chosen also by the combination or the synergy to our industrial partners, because in addition to the acceleration batch, we try to come up with a concept at the end on how the startup and the corporate can actually join forces and work together, and then directly move onto a pilot project to already test the cooperation. This is also something that we are doing in our validation package. There we have more established companies, more established technologies, and skip the acceleration part, but also work on a concept on how the industry and the startup partners can work together, and then move over to a pilot project. That is shown here, how we do it. So first phase is always the acceleration. It's 12 weeks with 6 focus weeks. We provide the grant for the startups. So even that international companies or international startups can actually move to Hannover to take place at the presence weeks we offer here. Then at the end, we always have a demo day. At the jury panel, there's a quality check if the concept of the pilot project that was worked together with the startup and the corporate is actually matching the demand of the corporate, and then we move over into the integration project, where we also provide an additional budget of up to 40,000 euros per project, and there is that is the phase where the startups and the corporates are trying to really work together and understand if they are then moving on to a commercially viable bilateral program. And this is the goal we always have, to bring the corporates and the startups into direct interaction. As I said, this are we doing also with the later stage startups. We shortened the ramp up period, so we skipped the acceleration program, but in the end, there are many ways of including the established technology or established products into the industrial environment, and bring the good that is our startups doing in the small just on a globally scaled level. Here are a few examples on what we did so far on these pilot projects. We had been in the aquaculture phase. We had been in Africa already with Contagra here, or with cropped, or we are trying to optimize how fertilizer is being covered with biological sources like biovec. And this is not all being done by myself, but the whole team of RootCamp. I built the RootCamp up together with Gaia, The coaching is also done by Casper. We are running public project as well, organized by Ilka. And the rest of the team is also helping us with conducting the acceleration program. The next application deadline is the 16th of January. There we will try to collect the applications, and the program itself will be starting in the last week of April. Now we are turning into the topic of circular economy, initiated by our partner K+S. We try to see how the processes can be circularized, how we can recycle macro or micronutrients. And as I said in the beginning, we are an innovation hub with multiple partners. So we try to not do it only alone or bilaterally, but we try to open up and have an open platform here, combining different partners along the value chain and identifying gaps or positions where actually the innovation of startups can be specifically positioned and where it can bring the best value. So it's also potential for startups to not cover a larger area, but to actually be guided into the position where they can distribute the value the best. That was it from my side. Having said that, I'd like to hand over to the first speaker, Matthias, who's running the circular economy activities at K+S. Matthias, would you want to share your slides?
Yes, thank you, Philip, for introducing. So let me share the slides in the right way. So hopefully you can see my screen.
Yeah, perfect.
So as Philip said, I'd like to give you a short view on K+S, as we are a mining company and mainly, of course, in the conventional mining. So we also have a look since a couple of months, even more than a year now, on the circular economy topics. And as Philip said, we asked the RootCamp team to offer us a badge or to provide a badge on the circular economy topic, and also, of course, with the specialization on nutrition. So that's why actually we like to give you a view how we see it and where we are coming from it. As you know, we are miners, commodity products is our base product, so we are doing normally millions of tons, and we are not taking too much care on smaller amounts. But nevertheless, we know that the kind of precision farming is getting more and more important. And here we are looking also in the kind of recycled product waste streams to subsidize and to even expand our portfolio by nutrients we don't have today, maybe in our portfolio, or even to replace current products we conventionally produce by waste stream productions. To give you a little bit to show what is actually the driver for us for circular economy on K+S, we actually see a couple of different topics. The first one is actually what we normally see as a threat for our business is regulations. In the circular economy, it's other way around. Actually, the tightening of regulation is actually the enabler, the key enabler to run circular economy topics, to go into recycled or waste streams and to use them. There's a lot of challenges for many industries in the world. So there's a high risk of extra cost, disposal cost, until the point that you can even risk your business and to stop your operations, because if you don't find a suitable way to get your disposals recycled or reused, there might be the risk that the regulation is forcing you to stop operations. So this is driving a lot of new projects, a lot of new ways to do business or to do management topics out of the waste streams or disposals. Waste products itself, of course, we are looking with our partners, especially from our customer side, what kind of waste products they are generating, they're producing, because we do it quite easily. We say, okay, they use our potassium, they use our chlorides, sodium chlorides. So not all of this will end up in the end product. So some waste streams are starting up on this. So that's why we get into talks with them. We see that they have disposal problems, that they have regulations on their business, that they get new regulations to reuse, to recycle. And that's actually where we see ourselves at the end of the stream to say, okay, let's take back these products. Let's reuse, let's recycle the nutrients out of this waste streams and to bring it back in our stream. And it's, of course, for us, as said, beginning commodity company, we see a great volume potential here because the waste streams, even most of them today probably are unknown that it's really a waste or a challenge. It's quite huge potential, and I will show it in the next slides on a couple of insights on projects we are already working on. And actually, as said at the beginning, we are conventional miners. Maybe the future will be like the urban mining, which is actually getting all these waste streams from the recycling industry, recycling partners, and that's actually why we are here, looking to our partners and to see if there are startups around showing us new ways of getting and recycling or producing nutrients from different byproduct streams, waste streams, recycling streams. And bring it in on one sentences, we usually use the phrase, which is, I think, widely known, that actually today's waste is our raw material for tomorrow. So this is something we are bringing into K+S to say, okay, yes, we do our conventional mining, we get our raw materials from the underground, but nevertheless, there will be in the future a bigger and bigger portion of recycled raw materials, of recycled nutrients in our portfolio, and which we're happy to explore and to go this way with partners from the startup scene, from industrial, from our customers. Giving you a glimpse on what we're already doing beside the RootCamp activities. We have published, I think, in summer in partnership with our partner Sinnes Fertilizer, which is a Swedish startup working since, I think, now 4 or 5 years into the markets. They established a process how to use a byproduct from the battery industry, e-battery industry, to work around and to create an added value fertilizer out of it. The way they are doing it is actually not a rocket science. It's a well-known process, even for us. They need to have raw materials from our side. They use the bystream of sodium sulfate, which is actually a very commodity product into the industry. Nevertheless, if you are following up the e-battery industry or announcements in the last couple of months, even 12 months, you find out that in Europe we have plans for more than 20, 30, even 40 different plants to be built, gigafactories. So this is an immense waste challenge. Most of them are not yet familiar with, because it's a nice product, it's a green product when it comes into the car with the electricity, but it needs to be produced. And the production is a chemical process. And in a chemical process, you have always byproduct streams. And due to regulations, coming back on my slide before, all these companies will face that they are not allowed to put these waste streams into piles or water streams, rivers, oceans, or whatever. They have to reuse it. They have to recycle it. They have to resell it. And that's actually the solution Sinnes Fertilizer, or Sinnes itself, provided their partners in Sweden. Actually, the major partner is Northvolt, which is probably pretty known. They're using our potassium chloride and formulating it together with sodium sulfate into an SOP, which is a potassium sulfate. And this is a kind of a specialty fertilizer product we are taking off together with them and selling into the markets globally, and as a, of course, sustainable fertilizer. So we like this idea how Sinnes is approaching this, making a very sustainable green fertilizer. Luckily, we can say they are producing it in Scandinavia and Sweden, so they are also using hydropower, so the energy is really reliable on no CO2 impacts. And to show that this idea is not just an idea, I gave you that we signed our LOI and our contracts in summer. And in the meantime, I think a couple of weeks ago, they made a very successful IPO on the Swedish Stockholm Stock Exchange. So we are pretty happy. This is from the numbers a really big project for them, for us, because they are planning to have at least 4 plants all over Sweden. The volumes will have a major impact on the balance for the SOP for K+S. So that's why we are closely cooperating together to work out that product, and for sure somehow it will subsidize or expand our portfolio with a sustainable fertilizer. That's the target, and it's for us it's a very nice, very good sample for circular economy, because we are reusing something which used to be dumped even in the sea. It was allowed by regulation, and now needs to be recycled. And the future will be very interesting because, as I said, there will be a lot of gigafactories in Europe, and many of them will have a waste challenge. And this is actually we are facing off, and we see that there's a good chance to get back our nutrients, and to make a circular business out of it. Another topic, just to mention it, and my colleague Daniel from Emscher will deep dive a little bit more on this. We are looking also on the phosphoric topic, phosphor recovery. Here, actually, we see it from the other way around. Today's world is that the German government already created a legal framework, which is quite unique in Europe. There's an obligation by 2029, 30, that all the phosphoric has to be recycled from the sewage sludge ashes or from this waste stuff. And this is quite unique, because it gives a kind of clear outlook for the industry, for the partners, what to do and when it will be a business or when it will be a necessary by legal framework. Technologies are still being tested, pilot stages. This is a little bit different to the topic before. There we have a very basic technology, well known. Here there's a lot of research done. A lot of companies are working on this from different stages. You have big names like Remondis, Veolia, but you also have a lot of startups in this field like Easy Mining and NN. So it's a very interesting field. Ourselves, we see ourselves not in the recycling industry itself to make the technologies, but we see ourselves in the end of the stream to use the nutrients, to use the phosphorus in our products. This is something we are looking very carefully in, because we used to do phosphoric products in the past from importing. So now we are only coming back if we can find the resources from recycling. This is a very interesting approach for us. So that's why we are working on different partnerships here, speaking with all the players, and try to be in line where and when the technology will develop. I mean, the effect is just telling itself. Of course, it's an interesting sustainable addition to our portfolio today. And nowadays, a very urgent topic is to reduce the dependency on imports, because more than 50% of the phosphoric is today, or was coming, that's why I say yesterday, coming from Russia. So, which is not an option at the moment, and for the probably near future anymore. The circular is just to show a little around where it comes from, that it's a full circle of recycling. Actually, the production of this phosphorus is coming from ourselves. We are the producers. This is just to give a picture on this. Yeah, I mean, that's just a very short glimpse from K+S. We are also working, of course, on a lot of different topics. We are very keen to be, let's say, really surprised by startups to show us where they see potential from waste streams, from byproducts. That's something we know ourselves. We are on the very beginning. We are starting with the macronutrients, which we know the best. We are very keen to see what is kind of happening in the macronutrition segments. We have a lot of projects in the field of ash to salt, ash to minerals. So where we do also the recycling and takeouts from the sieving ashes, from the shimmy ashes and an end. So this is a very interesting field for our industrial business. But our main focus is, of course, the nutrients, recycled nutrients. And as said at the beginning, the circular economy is already a cornerstone of our value chain, added value. So thanks for listening. That's from K+S side.
Many thanks for showing your side, for naming the challenges, but also already having a best practice example on how industry and innovators are able to work together. I mean, for both sides, it's very important, but also for the startups, and they're doing good in the small, and you're the level that enables them to actually scale and bring also security in their business planning.
Absolutely.
Let's stick to the large volumes. I'd like to hand over to Daniel from the Lippe-Verband. Can you tell us what is actually being done with the wastewater, and show us a little bit on the dimensions we are expecting that are typically not so familiar in the startup environment?
Yeah, thank you very much for the introduction again. And thank you very much to Matthias for giving a good link to our activities and our questions. My name is Daniel Klein. I'm working for Emscher Genossenschaft and Lippe-Verband in the field of new technologies, assessment of new technologies, optimization of existing technologies, and also on R&D projects. And since phosphorus is a new topic for us when it comes to recycling and recovery, this is also in my field. I will give you a short overview on Emscher Genossenschaft and Lippe-Verband. We are river managers, and and we are two public water associations since more than 100 years, and we are working in North Rhine-Westphalia in Germany. You see here Europe, Germany, and North Rhine-Westphalia, and the two areas of Emscher Genossenschaft and Lippe-Verband. Emscher Genossenschaft is managing the whole catchment area of the Emscher River. In the center of the Ruhrgebiet, you see the cities of Essen and Dortmund as 2 points, but there are a lot of other cities inside. So really densely populated, industrialized area. The Lippe-Verband is working in the Lippe catchment area, which is a little bit more rural, but even there are a lot of cities, smaller towns, and so on. Those two organizations are working closely together, especially in the organization. But of course, the areas and the wastewater treatment plants, for example, are separated because they are either Emscher Genossenschaft or Lippe-Verband. So that's where we are located. And our topics are everything around the water cycle. And when I say water cycle, you see already that we are talking about cycle and circular systems, especially when it comes to water in the cities, bringing it back to the soils and not discharging. It's a big topic today. And you see here we do everything around the water cycle, from water catchment to flood protection to wastewater treatment to sludge disposal and so on. What we are not doing, because we don't have the sources here in our region, is we are not doing drinking water. But there is no drinking water sources here. What's not mentioned here on the slide is sludge, and sewage sludge is a source of nutrients, especially phosphorus, nitrogen, of course, the carbon, and that has been used in larger scale as a fertilizer. But now, we heard it already, regulations are getting stricter and stricter, and the direct recycling of sewage sludge is more or less completely forbidden. Not completely, but there's some exemptions, but generally it's not more possible. So that we have to think about other ways to recycle the nutrients that are inside wastewater and bring them back to the cycle. So just a short overview about Emscher Genossenschaft Lippe-Verband again. We do manage the two catchment areas of the two rivers. We do everything around the water cycle since more than 100 years. So coming to phosphorus. Phosphorus is a new topic for us, not when it comes to treatment, because of course wastewater has been treated with regard to phosphorus discharge, but phosphorus recovery is new. And as Matthias said before, it is mandatory by 2029 or 2032, depending on the size of the wastewater treatment plant, but that's more special thing. In general, it's mandatory for most of the wastewater treatment plants. And our approach to P recovery is we want to do it regionally in cooperation with partners. We are assessing different technologies and options to find the best solution. As Matthias said before, there is no standard solution by now. It's a new topic, just a few examples of large-scale plants that are beginning to operate, but basically it's still on a not lab scale, but pilot scale, study scale level. So that's quite a challenge because we only have 7 years to do it. And if you do it, we want to do it integrally, and we want, of course, bringing back the phosphorus back to industry or back to agriculture, where it basically comes from, to close the cycle and to do our part in the circular economy. Yeah, as I said before, it's not yet standardized. We don't have the technologies to do it. So we are still working on large-scale research projects to find the best solutions and to especially create the link between our removal or our recovery and the actual recycling of the phosphates we have removed or have recovered. So I just mentioned one project because it's the largest one, and there are some, it's sponsored by the Federal Ministry of Education and Research, and the whole funding is called REFOR, and there are 7 different large-scale projects in Germany. They all focus on large-scale industrial pilot plants to demonstrate the phosphorus recovery. And what they all have in common, they are focusing on bringing back the phosphorus to the users, because that's now the important task. We only have 7 or 10 years, so we have to close this and bring them together. In this case, our project Amphore, we are working with 3 other wastewater or water management companies in our region, also public water boards like the Ruhrverband, who is also coordinating the whole project and who is responsible for the Ruhr catchment area in the southern part of North Rhine-Westphalia. We are working, of course, with universities, and you see below associated partners are basically from the fertilizing industry, because we want to close the cycle and not only remove or recover phosphorus and then we don't have no idea what to do with it. So that's quite important for us. We heard in the introduction that the potential is quite high. So again, you see the project area with the Emscher Genossenschaft area in blue. You don't see that much blue because everything is residential area. So that's red. So that's overlapping the blue of the catchment area. In green, the Lippeverband, the Ruhrverband in the south, Wupperverband here. Just to name a few figures, we serve together 12 million population equivalents, coming half from the industry, coming half from actual inhabitants. And together we have 12% of the sludge incineration capacity of Germany. Potential of phosphorus, 4,700 tons. And we are focusing on the production, finally, of phosphoric acid. So the potential is about 20,000 tons of phosphoric acid for the market. We are focusing on phosphoric acid because that is probably, as it seems now, the best product for market and for bringing it back to the market. There are other options to recycle phosphorus, but phosphoric acid is probably the most important thing for the market. Also in this project, we're focusing on that product. When we see it for Germany, probably the whole potential of phosphorus in wastewater streams, basically in sewage sludge and ash, is about 50% of the whole demand of agriculture, roughly, depending on your calculated. So that's quite a big amount because it's coming from agriculture and then goes back to agriculture. So this is quite a large amount that could be covered by wastewater streams, basically. So something like that we have seen already before. What we finally want is to close the cycle of phosphorus. that has been closed partly before using the sludge in agriculture. That's now forbidden. So we need a different option, and that is recovery of the phosphorus inside the ashes or the sludge, and then bring it back again to agriculture, basically. So you see today in red, this is the problem. Today we incinerate all the sludges, bringing them to landfills, and then it's, when it comes to phosphorus, then it's lost. And on the other side, raw phosphate is mined from global reserves by mining processes. And here in the lower part of the slide, there is no link. And what we are doing in the project, and what's likely the main option for whole Germany, because we do have a lot of sewage sludge ashes, is to bring back the ashes to wet chemical processes for phosphorus recovery. That's complex. That's a lot of chemistry, that's lots of energy, but finally producing out of the ashes phosphoric acid, and that's a base material for fertilizer industry and for the industry in general. And this is the circular economy part for phosphorus. But I think this is just the beginning, because we still have nitrogen in wastewater, large amounts. We still have the carbon, which is now used for energy production, basically, but could also be used for other applications. So I think phosphorus is just the beginning for the whole wastewater sector to get more into the things of nutrient recovery, of circular economy. So just a few overview on what we are doing in the project. I think I will skip it shortly. So we are focusing on the regional options, on the complex situation, because we are talking about large-scale chemical plants to recover phosphorus. We are focusing on the technology. This means we are creating or building a large-scale pilot plant, industrial-scale plant, not full-scale, but small full-scale, to get more into the technology of phosphorus recovery. And we are closely linked to the region and the users, because this only makes sense if we go into actual recycling and not just removing it and then don't know how to use it. So this was a short overview on our point of view on phosphorus, and that was my presentation. Thank you.
Yeah, many thanks, Daniel. Can you, one question directly towards it, can you say where the biggest challenges are? Is it more the process, establishing the process still? Is it more the economical perspective that it's actually a commercially viable process, or is it the pure scaling that in the next 7 years the plans need to be constructed and the whole process needs to be changed into this way?
Yeah, I can come starting with the third question. I think the time frame will be a problem, because 7 years is really short, because we're, as I said before, talking about large-scale industrial plants with a lot of input materials, a lot of output materials, side streams, energy demand, and so on. So this will be a problem. When it is then constructed, I think it's difficult to find the best way to do it. In general, the technology are quite clear how it will be done. It's most technologies are now focusing on ash, because we all have the ashes. There are other options. I think we probably hear later about that. But it's focusing on ash. And basically, you always have to leach the phosphorus out of the ashes. Then you have a liquid phase. You have to separate the liquid phase from the leached ashes. Then you have to clean it, and so on. So the process is quite clear in general. But I think it's difficult to find the best economic way. Of course, economy in the public water sector has to be discussed, because we are financed by the public and we have to do this. So in general, there is a financing. But anyway, it makes sense to do it the cheapest and the best way, because we want to do it also and do something with the phosphorus. So yeah, it will be a challenge, but I think it's difficult to find today how to do it. Where do we build it? Because it's a lot of transportation. Will it be centralized, a little bit more decentralized, and so on? I think this will be the question. Microphone? Okay.
Yeah. Now turning to one of the points you mentioned before, actually the seed content in the wastewater. So I'm handing over to Sebastian, who is actually interested in specific wastewater streams or low value residual streams. Let's put it this way. For you, it's still a value in it, and especially when there is some salt involved in the streams, in the water streams. That is highly interesting for you, Sebastian. Do you want to share your slides?
Sure, Philip. Thank you very much. I will share my slides very quickly. Please let me know when you can see it.
Yes, it's up and running.
Good, excellent. Yeah, Philip, thank you very much for the introduction, and it was very fascinating to hear what the colleagues had to say and were presenting. So indeed, it's a good hook what Daniel said, and so we are dealing with wastewater as well. So I'm the CEO and the founder of Elb Element Bioscience, and everything we do evolves around converting wastewater into valuable products. And wastewater, when I say wastewater, specifically, I mean polluted industrial wastewater. And actually, there are around 140 million tons of industrial wastewater being produced every day. 140 million tons every day. And as of today, in best case, this wastewater gets treated in the right way and then disposed. That's at least here in the Western world the case. Worldwide, that's actually not so much the reality. The reality is it probably gets just disposed, and the sources for this wastewater is various. So we have aquaculture, mining, oil and gas, pharma, chemicals, food, agriculture, pulp and paper, and tannery. A lot of different wastewater sources where these 140 million tons of wastewater are produced every day. And in best case, it's considered to be a challenge. In worst case, it's a problem. We actually believe it's a great opportunity because as of now, and I can highly recommend a report from the European Investment Bank dated May this year, where they are talking about wastewater as a resource. This is exactly what we want to do and what we want to consider the wastewater. It's actually a great opportunity. It's a great resource because it still has a lot of organics and or nutrients inside. And so we want to make use of this wastewater and building a, let's call it, unique, proprietary and scalable, not waste to, but wastewater to value biotechnology platform for turning the wastewater into valuable products. And we are serving various different purposes here. The main purpose, obviously, is circular economy by upcycling the wastewater into a product or into product recovery. And then depending on the product, that is the result of the upcycling. We are also contributing to the decarbonization, which is a very important topic as well. So in some way, it's a connection between circular economy and decarbonization. And then it's improved efficacy by using as much as possible of raw materials that are available. And then the last point would be supply security, especially in today's times where supply chains and maybe also, let's say, sources of product are constrained in some way or the other. So this is what all this technology platform is actually about. And this technology sits on two major unique advantages that we have. One is that we have unique expertise in using highly specialized microorganisms, their media, process parameters, cultivation, and the requirements for the scale-up. And the second expertise is in digitized process analytical technology, PAT, which is very important for continuous bioprocessing. So the biotechnology platform that we are building is focusing on continuous bioprocessing. And for continuous bioprocessing, we need the specialized microorganisms, but not only the microorganisms. And the second step, and that's maybe even the more important step, is we are making use of digitized PAT, and we are working with something like digital twins, for instance. So we are generating actually a lot of data, and the data is needed in order to get a good understanding and knowledge about what is going on and about the different factors that are influencing the productivity of the microorganisms. And once all these factors have been identified, and once we know how the factors actually influence the productivity of the microorganisms, then we are actually also able to influence those and control the process. So and that essentially means that resting on these two pillars, so expertise in specialized microorganisms and in process and analytical technology, we are building this unique toolbox for transforming wastewater into valuable products. What does that mean? How does it actually look? So that obviously can be quite high level. So in reality, this looks like this on a very simple format. So we have a production side that is making a certain product. And usually when making a certain product, wastewater is produced, obviously not on purpose, but as a side stream. And then in general, this wastewater gets piped through pipelines to the wastewater purification unit. And with our technology platform, it will be possible to put a bioreactor in between, actually. So the wastewater is flowing through this bioreactor, and the microorganisms inside the bioreactor are doing their thing, basically. They are metabolizing the nutrients that is inside the wastewater. And by that, they are purifying, to a certain extent, at least, the wastewater. And in the second step, they are either producing a new product, or they are actually recovering a certain product that is already or was already before inside the wastewater. And in the third step, that would be, in best case, the purified wastewater would be then, let's say, suitable again for re-engaging into certain production processes. So it's basically a three-step value approach. So purifying to a certain extent, product production or product recovery, and then in best case, it's a re-engagement of this wastewater stream after purification. And the process features here are in general, so this is applicable for most of the processes that we are developing. So they are running at very mild temperatures, so around 40 degrees Celsius. And by the way, we can make use of the heat that is being produced already at the existing site, at the existing production site. So it's very mild. It's quite easy. It's an automated process. It's running 24/7, 220 days. Basically without any additional manpower needed. It's very flexible. So once we change the microorganisms, it takes only a few days and a few adjustments. And on the same bioreactor, we can also make other products. And the main feature here is basically we are not using any fresh water. So we are saving freshwater resources by using already used water, as we speak, wastewater. And wastewater is very important in this case here, because it's not only from a circular economy perspective very interesting that we are upcycling the wastewater, but the wastewater is giving us also a tremendous advantage. And the advantage is that in combination with the microorganisms, that we have one major benefit, and that is the probability of contamination is extremely small. Obviously, it still exists, but the contamination probability is, in comparison to the other standard production processes that we have, is extremely small. So if we look onto one side of the production processes that are available within biotechnology, so we have a batch production process, then we have a fed batch production process, and on the other side, we have a continuous bioprocessing. And all these these three different processes, they have advantages, they have disadvantages. And for the batch processing, the advantage is it's very easy, and it can be, at least on paper, and that's one of the major downsides then, it can be, at least on paper, it can be scaled up to 500 cubic meters. Now, at the same time, once the process started and the reaction, let's call it, is initiated, one has no control or influence anymore about what is actually going on inside. and it needs a lot of cleaning, sterilization, etc. for a batch process to be successful. So the efficacy of such a batch process is actually not very high. And then we move to the fed batch and then to the continuous bioprocessing, where we are adding more and more nutrients to the process itself. And by doing that, we are gaining more and more control over the production process itself. However, the downside here is usually the risk of contamination. Now, in this case, and that's why it's very important, our bioprocessing actually has no real contamination threat because of the wastewater and the microorganisms we are using. Still it exists, but it's very, very small. And so we are eliminating, in that sense, the downside of the bioprocessing and still gaining all the upside of bioprocessing, which is essentially very high control over the production process and very, very high productivity, which is much less the case when we look onto the batch side. And that is very important because essentially what is missing in the biotech world still today is I mean, we have all kinds of different new developments, and one is obviously the gene modification topic, but still we have not really found a way of how to scale bioprocesses in the proper way. And when I say scale, basically it means comparable to what the chemical industry is doing today. And we are still quite far away from that, but we will need to reach this kind of productivity and efficacy level in order to be able to produce enough product through biotech processes, and B, also to serve the world with products. So the scalability is very important and is very much needed. So coming back to this no contamination topic, this actually allows us to scale the processes much easier because we do not need to do sterilization, and because we don't need to do sterilization, we are able to scale the processes much easier and much higher than usually. And that means that we have a much higher space-time yield, so the productivity is very high. And at the same time, that would require lower capital investments per output, essentially. So, and when I say scalability, we are talking here about technology, or let's say bioprocessing processes that are able to run on continuous bioreactors of up to 100 cubic meters per hour, which is quite a lot. So that's it from my side. Thank you very much.
Yeah, many thanks, Sebastian. Just one question. Can you say what is your ideal wastewater? So what do you normally have? Is it high salt, high carbon content, or what do you actually need to have your process run ideally?
So obviously there is some sort of ideal wastewater. It should have a lot of organic, that would be good, and all kinds of other nutrients that would be good as well. But it always depends a little bit. So the microorganisms we are using, they are very flexible. They can use all kinds of different organic sources, basically. So here we are not very much limited. It depends a little bit, but let's say organic would be good. A lot of organic, as much as possible, that would be ideal.
Perfect, many thanks. So now switching to a different continent, going to Diego, who's live from Argentina. You're also in trying to use the sludge from the wastewater and with the biological hint, or with biological know-how, turn it into a valuable product that actually goes back into the agriculture field. So please share your story.
Well, hello, I'm Diego. Let me share my screen so you can see my presentation. Yes. So as Philip was mentioning, I'm from Argentina, and we founded this company with a partner in Germany, and this company is from Hannover, and we are developing a biofertilizer from slash biochar, adding some plant growth promoting microorganisms. Our team is formed by Professor Jutta Pappenbrock from Leibniz University in Hannover, and she has a strong background in plant science. I some time ago, I founded a company here in Argentina for the development of microbial biofertilizers. And I have a background in microbiology. And our first employee is Kushal Bose. He has a master's degree in plant science too. And he's working also in Hannover. What was already mentioned by Matthias and Daniel, what motivates us is the growth population in worldwide. So this growth population is associated with a need of food, an increase in food demand. And this food demand also needs some supplies, and food productivity, as all of us well know, are driven by chemical fertilizers. But when we use these chemical fertilizers, or we not use them properly or overuse them, we have some environmental problems. We might lose some soil fertility, and so we are trying to avoid these problems by developing a biofertilizer that combines two components. On one hand, we're using slash biochar and some growth promoting, some plant growth promoting microorganisms. And how does it work? Well, biochar is basically is biomass that is processed through a pyrolysis process, in which carbon are condensed, right? And you get rid of all organic compounds on the slash, and that creates a matrix that is very porous, in which we can, this porous matrix has a high surface area, and in which we are adding these specific selected microorganisms, combining them according to the plant or environmental needs to create this biofertilizer that combines the benefits from both components. On one hand, the biochar applied to soil has a higher water retention capacity. It's an organic material with a high carbon sequestration rate. And the microorganisms, depending on what we are inoculating on the biochar, can produce, for example, some plant hormones that modulates plant growth, but also can fix nitrogen from the atmosphere, or solubilize some nutrients. As Daniel was mentioned, in slash we have a lot of phosphorus, so there are some microorganisms that can solubilize phosphorus. This creates This creates a product that that increases plant yield in a sustainable way. About carbon sequestration, as was mentioned before, there are many nutrients that are contained in slash. And about carbon sequestration, particularly when the biomass is processed through pyrolysis, the carbon is condensated and it gets very, very stable. So when you apply it to the field, this remains stable for many long years, avoiding the loss of CO2 that we know the effect that it causes in greenhouse effect and world warming. So as you can see in this work from Lehman, he investigated how much CO2 is released by biochar, and you can see here that almost 50% of the CO2 is retained in the soil for almost 5 years, or 5 to 10 years, whilst other sources of carbon is releasing the CO2 almost in 1 year. About nitrogen, as I was mentioned, this porous matrix that is created on biochar can retain, for example, nitrogen from fertilizers, avoiding leaching to the groundwaters, underground waters, but also can retain some nitrogen oxides that are released of the atmosphere. But this work from Jean, they research how soybean plants are in growth on soybean plants are increased by the application of 1.5% of wood biochar, especially based on nitrogen fixation, because as this matrix can allow microorganisms to grow better and develop protected for the environment in these pores, it also increases in biological nitrogen fixation. And about phosphorus, as also Matthias and Daniel mentioned, biochar slash has a higher content of phosphorus, for example, than other sources. And here in this work from Jean, they evaluated how much phosphorus is containing on slash compared with wood, that are two different sources of biochar. And so that's why we pick, or we're producing this slash, this biochar from slash to take advantage of this phosphorus. Also, the main sources of phosphorus on the biochar are insoluble, so they are not properly used by plants. But that's why we are actually adding some microorganisms to solubilize this phosphorus and make it more available to plants. And as I was mentioning before at the beginning, we are selecting and combining microorganisms that we inoculated on the biochar, depending on the trait that we are interested in, or the environment demands for plants and how plant or what nutrients plant needs. And from these traits, we have some direct effects. For example, nitrogen fixation, phosphorus solubilization, or potassium solubilization that can be in the soil or in the biochar, and also the pheromone production that I was mentioning before. But we can also address some indirect effects on plant growth. For example, when we are thinking about how these microorganisms can help plants to tolerate some pathogens, some plant pathogens. And here we have some, for example, mycoparasitism, antibiotic production, or lytic enzymes. And our company is recently founded. We founded the company in August of 22, so we are quite young, but we have some, and we are currently developing a prototype of the product at the lab scale, and we have some experiments on the greenhouse. But many of these experiments are being made in the framework of or collaborating with some other research groups or companies. So I can't mention too much about it because this information is not yet public or published. But I can show you, but there are some very encouraging results. Some of them, for example, is this experiment we made on barley from weeks. It's very short, but we have a very positive impact on the combination between biochar and trichoderma, which is a fungi that we are inoculated on biochar compared with the control. And what we need today, we are, as I was mentioning, developing a prototype that we hope we probably get it from first quarter of next year. And we're looking forward to collaborate in field trials to really test our prototype in real field conditions. And in this case, this will allow us, not for the next season, will allow us to adapt our product to different conditions and continuously improve our product. And well, thank you. I thank you for your attention, and I hope that you get interested and can collaborate together. So I can hear you.
Stuck to the topic too much. Just a question. Do you need to take a certain type of sludge, or does it need to have a certain cleanliness or obstacle? There are ways to actually also reduce the amount of contaminants or heavy metals biologically, or what is the ideal method that you are starting with?
Well, we're working currently with some slash biochar that is produced in Denmark by a company there. They are supplying it for us. And in the pyrolysis process, all organic contaminants are eliminated because of the temperature. The biochar is produced at 750 degrees, so every organic compounds are destroyed. through heat, and about because the slash that we're using is city wastewater, so we don't have too much inorganic contaminants there. Mostly we are getting use of the phosphorus there, and well, other nutrients too. And as Matthias mentioned, we have some other micronutrients that are also very interesting to apply as a fertilizer.
Perfect.
Actually, last week we get sorry. Actually, last week this associated from Denmark told us that they get a permission to use this biochar in field trials. So that's a great news for us.
Perfect. So we are coming to an end, and I'm about to close this round. Matthias, what's your perspective on the circular nutrient? So you're dealing with hundreds, millions of tons of fertilizer, and now we are also having here quite very young companies. We are facing lots of scaling issues on, just larger structural topics like the phosphate, as Daniel was telling. So what is your position on, from a perspective of a large-scale producer of nutrients? What is needed, and what are the potentials that these more decentral ways are able to being brought by you in the market, or being of value that you are contributing?
A lot of different points. How to start? Maybe the cultural clash, because I like this. We as a corporate, and even a double corporate, because we are corporate in a commodity environment, millions of tons, so only used to big tons, counting our product in vessels or trains, and then talking to young startups with telling us, guys, you need to be more precise on the nutrients. And how to say, fully right. I mean, this is a kind of precision farming. And it used to be precision farming using all the GPS and whatever things. No, it's today also use less and do more. This is the point we have already on our target list. It's a cultural shock, cultural change for us, because of course we like to sell our products. Anyhow, we will do this for the next centuries. We don't know, have no doubts on this, but we like to add. We like to get used to this recycled, to this sustainable nutrients. And the way is, yes, exactly, to combine our know-how, our agronomes, our access to the farmers, to the regions, to enable startups like Diego to do field trials. I mean, this is something which is for us normal. We would be happy to exchange here, because this is what we do on a regular basis. And this is exactly what I like, what we like to learn, and to combine the knowledge. Be precise, do less, and get the same result. We are coming from the other side, do a lot, get the best results as well. But the future will be the combination of this. So I'm pretty happy. Yes, there's a lot of challenges, regulations, as Diego said. Denmark allowed, probably Germany not that fast. So, but this is also a kind of we need to bring in from K+S, because usually say we are sleeping with the fertilizer regulations under our chest, so we know them the best. And we know how to work around, how to get all those regulations in line with the new nutrients coming from the waste streams. And I know that regulations, they don't like the word waste at all. So this is the beginning. Even if you speak about waste, they stop talking, because no, we are talking about fertilizers. So, but recycled, it's a kind of using waste. As I said, today's waste is our raw material for tomorrow.
Yeah. Daniel, last statement from your side. So I like that you are already reaching out to a large a number of stakeholders, participants in your processes and in your projects. So what can you actually say about how you will go forward? How do you share your experience or the results with the partners on the market, with other organizations like the Emscher Lippe Verband? And do you see changes or chances to actually get startups involved in there, or what is the size where you actually start saying, okay, now we are talking?
Yeah, it was interesting to hear what Diego said concerning the biochars, because we always had the discussion on how to integrate, for example, pyrolysis processes into wastewater treatment plants. The problem is, especially in Germany, I would say, wastewater has always been regarded as the waste. So we have a centralized system with end-of-pipe solutions, mixing everything together, have large wastewater treatment plants, and then now we are starting thinking to how to remove again the nutrients to use them. So it would be much easier when we could completely rethink the new system to start at the beginning. For example, urine, probably you know, all the nitrogen is in urine. You mix it with a lot of water, bring it to wastewater treatment plants, and then it is our main problem is to get rid of the nitrogen, because that costs a lot of energy. So when it comes to circular economy, the system is kind of, yeah, probably not the best one, but we have it. So that's why we are thinking, or we have to think about end-of-pipe large-scale solutions, because we produce the wastewater treatment ash. And then we have to start with the ash and not with something before. But I think the way will go in this direction. It's not only phosphorus, but as I said before, it's carbon. Carbon for us is basically an energy source. We produce methane gas and use it for energy production. But farmers need carbon, especially now, considering the war and the complex structure with agriculture. So we have to rethink something. And I think this will be an option in the next years or probably decades to change the system a little bit more into the reuse or the use of nutrients. And then I see a lot of options. But today we are working in a large scale, mainly centralized system. And that's our framework to act. But I see options for the future because we have to rethink it.
Yeah, growing big was also the core point of your presentation, Sebastian, that your technology enables just large-scale continuous processing. So you are not as much into the wastewater from residual water streams, but more on the more specific industrial source. So what do you see there? What are the drivers that enable the industrial owners of the waste stream of the facilities to be able to include your technology with an investment with involved capex into their value stream?
Yeah, that's right. So we are focusing on industrial wastewater. And here we see ourselves as a technology supplier, basically. So we are not making or we are not running the bioreactor ourselves, but in the end, we are offering licensing process technology, basically. So obviously, what is very important, apart from circular economy ambitions, obviously that needs to be viable and feasible from a business side. So it's not, I mean, being, let's say, very generous and doing good is one thing, but still it needs to be paid and it needs to generate money. So for us, it's very important to get a good understanding what the company is looking for, what the product ideas are, and then we are tailoring around the conditions of the wastewater. We are tailoring around and developing a production process, which essentially ends making the product that the company was looking for. So that's the idea, and that's how it works. But in the end, it's important to, let's say, combine circular economy and on one side, and then still the business side on the other end. This is very important because in the end, a company can only run if it's making money, like Matthias said. So, and without, let's say, making money, circular economy actually will not exist. So it's important to combine both things. So it needs to be a feasible and a worthwhile circular economy solution from our end that we can offer to the customers. And once we can show, okay, the process that we are developing, that we have developed, and will then finally make a certain product A, for instance, it is worthwhile and it is possible to sell the product on the market with a margin, actually. Because without a margin, nobody will be able or willing to invest.
Then here precision will make it feasible, I guess. So not just put it into the big stream, but see how value can be sourced in between or before actually the waste stream is then being combined with other streams. And Diego, we already had ticked some boxes here. So yes, paralyzed sludge is of interest. There are big issues and very costly processes of getting or making the nutrients from the sludge ash bioavailable. You have the solution for that. So how is your way of scaling, of doing the field trials where we have ticked the box already? But what's your way of scaling it towards actually a marketed product that would fill a train?
Well, yes. Actually, we realized that as long as we have cities, we will probably have a lot of sludge and a lot of nutrients that are discarded. So taking advantages of those nutrients is what really moves us, and getting back to the field and to food production that we desperately need. And about the scaling up, I think now at the beginning we're having this biochar from, as I mentioned, from this Danish company, but this process can be replicated in many places, so you can really use the nutrients that every community is discarding. And actually, as this product that we are developing has a great impact on the environment, I think that if we can use it in a large surface, the better it will be, because the larger the environment benefit will be. And so it's also for us, because we're reusing and hopefully selling a product that will be used hopefully everywhere. And so recycling these nutrients is very, very important. And as I know, well, as you know probably better than me, in Germany, the fields are not that big compared with what we have, for example, in Argentina or in the US. So thinking about how important agriculture is for our countries is a major thing. And we are thinking about starting there in Germany, but maybe probably in the future trying to scale up to other countries too, hopefully.
So that is always our aim, source locally and then spread globally, or source globally and enable it, the application locally. So final words, many thanks for participating in this webinar, for your insights. Many thanks for on the audience for staying in this stream, and please reach out to us whenever you have any challenges or solutions available, or you can offer any help to the startups, but also to the challenge providers in the industry. It's, I guess, a development that affects all of us. So again, many thanks for participating, and stay tuned for our next webinar. See you then.